So I'm here to present a bit of what's been going on in the IETF on the topic of BGP security. I co-chair a working group called Routing Protocol Security Requirements Working Group, actually, and our charter has a bit more to it than this, and you can find it at that URL. But basically, the idea is to derive requirements and do analyses of routing protocols, which will then inform routing protocol designers for current and future protocols about known and possible threats, mitigations, and things of that sort. OSPF and BGP certainly are things of interest to this community, and things that have already been have had some work done on them. And the idea is to have a focal point for routing people, security people, and of course operations people, so that the security people, for instance, don't have to follow all 10 or a dozen routing protocol working groups, routing area working groups, but we can all kind of come together in one place to discuss this set of topics. So this is unfortunately this is where how it ends up, a little graphic piece. We've got the Venn diagram, RPSec sort of in the middle, and we've got different. When it gets negative, this is how it plays out. We've got the routing protocol people saying this won't work, security people saying it won't be secure, and operations people just throwing their hands up and saying, you know what, I'm not going to use it. I won't bother. BGP security has been worked on since at least '97. I think at least a year or two earlier there were some papers on it as well. There's some different solutions that have been that there's been some work published on, and all have somewhat different sets of received requirements. Some different idea of what they think the problem is that they're trying to solve, and usually embed that in the work that that's been published. However, they're sort of different, so we thought we'd try and do it from the top-down approach of go back and derive an agreed-upon set of requirements, and then we can do a bit of analysis of how the different proposed solutions meet that. So far on the mailing list and the meetings, we've had a lively exchange among people with routing and security backgrounds, but definitely I think a dearth of input from you, the operational community, and we need to employ our best etiquette and talk, listen, be constructive. So here's a little bit of more background of what I see as some of the operational things. The known things that we've seen: improper route origination or propagation. Some are accidental and naive. These are going back a number of years, but accidental origination of Net 18, which is MIT's Class A, that send a lot of traffic to a small dial-up user in Florida some years back. And then there's the infamous AS 7007 incident where one AS deaggregated a huge number of routes and ran basically everyone's routers out of memory, and it was pretty nasty for anybody who can remember. Then there's the malicious ones. There's people originating antagonistic or competing announcements, whereas where somebody thinks an address prefix belongs to them, and they send it, they pop it up on this provider, and then another person says no, it belongs to us, and in the meantime they split the 24 into 225s and try and steal the traffic back, and that gets kind of nasty. And then there's the pop-up hacking that I've heard anecdotes on, and I've seen at least one instance of what seemed to be that with some of my own networks, where people pop up, use some unannounced space, they do their bad stuff, and then they disappear, so no one really knows who they are or where they came from. route filtering is current best practice. Hopefully, most or all of you do it. I know that's been the subject of earlier panels that I've been on at NANOG. But how do we check who's authorized? Really, I mean, when people say, okay, well, you've got a new customer come on, and they say, oh, I've got some legacy space that I'm bringing over from another provider. How do you know it's really their space? What do you check? Just a quick who is, or is that good enough? What if they've changed their name and they've gone through some corporate changes? How do we know it's really them? Then there's the projected operational problems, the ones that everyone's got the fear of God in them about session resets, data injection, and corruption. These are blind attack approaches. Then, if we take TCP with MD5 checksum options as the protection against that, do we get into other headaches with key management? How do we get the keys around? Rogue employees. What if somebody starts publicizing the keys of their employer, and how does that affect things? And what if somebody compromises a router entirely? Then they don't need to know the keys because they've already gotten in and can do whatever they want. Then there's the TTL security hack, so-called. What does that do for us if we've got a compromised router? Still, none of the existing solutions really is a full solution. Unfortunately, like a lot of things, it comes down to the terminology and getting some agreement. Unfortunately, usually through email, on what we mean by some of these different words: route, path, routing, forwarding. What's an update? What's a signature, a certificate, a hash, a key? What does something mean when it's encrypted versus signed? People use these words in imprecise. What's has a very precise technical meaning to some folks might be something that other people think they know what it means, but they're using it somewhat imprecisely. Neighbor, peer, AS. These are all can be confusing or up for grabs, surprising as it may seem. So we need to identify some operational practices. Also, I mean, this is an issue with the work at hand, which aren't necessarily reflected in the specification or in any other IETF document. Ways people use communities in their operational network, ways they use possibly confederations or private ASs. They have their own tricks or legacy configurations, and how can we analyze those if no one really knows what they are? If they're not part of something that's published per se. And some are essential, some are just hacks. Like I said, legacy or things that people use just to get a certain result. But we want to figure out what we really need to support in our requirements, and what's what can be set aside. One nice juicy topic is trust and authority issue. Well, how do we trust? How do we figure out how to trust each other? I mean, obviously, we come here and there's a lot of networking and we get to know each other. But and then there's some legacy business arrangements or active business arrangements. But how do we? How's that encoded on a technical level? Most of what's gone so far into the requirements is sort of sets aside how we establish that trust as slightly outside the scope of the protocol per se, and we're not sure if that's can we set it aside, or is it something we really have to take head on at the outset? And then how do we take what exists without replicating problems? I mean, obviously all the problems that occurred that I mentioned earlier, like the AS 7007 problem. I mean, all the people were trusted. Obviously, the trust was inappropriate or overreaching. So we don't want to just sort of put in a bunch of PKI or something and have the same problem again, where we say, oh, AS foo, AS1 or some is allowed to we'll just trust all the advertisements from them because we trust them. You know, that doesn't help guard against fat fingering or much less any malicious stuff. What information do we have to bring to bear? There's the current routing registries, number registries. Is it too inaccurate? What other choices do we have? So these are definitely open questions, and hopefully people will comment on them later during Q&A. Why do this in standards? There's, without some kind of standard, you know, an operational BCP, or you know, at the very least, if not a standardized and interoperable protocol or set of extensions, how can we really know what we're getting, and how can we come together as a community to implement something? If somebody else says, well, I'm going to do something, and you say, okay, I think I understand what you're doing, and the person, you know, one hop away says, all right, you say that your customer is doing something right. How do I know what they're doing, and how can I trust you? You know, trust them and trust you if I don't really have clarity about that. So that's why we need to standardize it. Need to take on the work in the IETF and have it validated in the operator community. So here's my advertisement, my plea for help. This is our particular information about how to subscribe, where the archives are. Please feel free to jump in, because there's a lot has gone by the boards, but I think you probably, just even based on hopefully what's presented here, you can make a useful and important contribution. So don't feel like you have to catch up necessarily to jump in with some kind of comment. And I'll try and grease the skids at on the mailing list to make sure that people are a little patient if somebody comes up with something that's a little you know, it seems like we've touched on it before. And there's the URL for the current document. Blaine is going to present a little more detail on that today. Panelists are Blaine Christian from KMC Telecom. Got a lot of background in ISP networks, worked at UUNet for a number of years. Then we've got Danny McPherson from Arbor, also been around the provider realm for a while, worked at the old MCI and then the old Genuity, then GTE, then Quest, and so he's been through a few. And then Sandy Murphy, we're going to have Doug Montgomery from NIST, was unable to make it the last minute for a family, due to family situation, and Sandy has agreed, because she's a sport and a true professional, to come in at the last minute and even work up some slides, a few slides to present. And she's done a lot of work on BGP analysis and of the current BGP spec, and so she's got always some good things to say. Hopefully, we'll have good interaction from the floor and maybe a few little panel discussions. So I'd like to encourage that later on. And without further ado, we'll have Sandy first, and then Blaine, who has the longer presentation. And Danny is going to. Danny's got one slide. That's great.
Anything that mentions a lively discussion in BGP security topic area I did check to make sure there wasn't any rotten fruit at the break. I'm at Sparta now. I was at Network Associates until about a year and a half ago, and then a whole group of us moved over to Sparta. So those of you who knew me as someone at Network Associates before that Trusted Information System, it's the same person. So there's two email addresses there. Both work. Both come through the my workplace. Just one is kind of historic. I'm going to talk about a sequence of ever-increasing protection, ever-increasing cost solutions to BGP security. I took this from the IDR vulnerabilities draft, so you may have seen this before if you've been following the field. First and foremost is peer-to-peer connection protection. You have to protect the transport. This keeps out the outsiders, the people who are hackers or just curious, from interfering with your peer-to-peer connection. The next three types of protection are ever-increasing protections for insiders, the people who are legitimate BGP speakers, but who have, for various reasons, faulty, misconfigured, or subverted, decided to produce something that they shouldn't be producing. First and foremost is the origination protection, some way of protecting that someone is allowed to speak the addresses that they're announcing. That's usually prefix hijacking. The next two are increasing protection levels for the AS path that's passed along in the BGP update messages as one of the route attributes. First is protecting the adjacency information that's in the AS path, and then the protection of the whole transmission of the route. So talking about the peer-to-peer connection, there's no real mystery here. There are two mechanisms for protecting the connection. There's the tried and true TCP MD5. There's IPsec, both of which can work for the peer-to-peer connection. TCP MD5 is old enough that it precedes some of the work in IPsec that was done to provide replay protection and provide for rekeying information. But the TCP MD5 stuff's been around so long that it is what is used most often. The problem that I hear over and over again about both of those techniques is the management of the security information. How on earth are you going to get keys to all those many, many routers? I heard AT&T mentioned as having 15,000 routers. I can't imagine how you manage all of that information. And then you not only have to get the keys there, you have to replace the keys occasionally. You want to replace them just as a good security move. It's been used often enough, you need to think about going to a new key, and you have to worry about the problem of you found out the key's been compromised in some way and you want to replace it with a new key. So how do you accomplish those tasks in any sort of reasonable amount of time with a reasonable sort of effort? And there's a real need for tools to help make this scale. Okay, so then origination protection. So you can have two kinds of origination protection. You can just have protection that'll show you that the AS is authorized to advertise the address. Or you can have protection that would say the AS is not only authorized to advertise this address, but it is now currently doing the advertisement. It doesn't help for those people who are using allocated but not yet announced space. It doesn't protect against those, just if you know that the AS is authorized. Okay, so then you have to delve into the deep and thorny question of just what exactly it means to have the authorization to announce an address. There's problems with people who don't have an AS number being allocated addresses. There are problems with addresses being announced by two different ASs legitimately at the same time. There's problems with what are you going to do about aggregates? What are you going to do if you have an aggregated address allocated to you, you sub-allocate to someone else, And how does that affect whether or not you can announce that address? What if you're proxy aggregating? So you have to decide what all of those things mean. You have to represent them in the information that you're getting. And of course, you need some sort of an authority, not necessarily, of course, a centralized authority, but you need some place to go to check this information. And there's all sorts of attributes about this authority. The authority has to store the information. The information has to be complete. It has to be accurate. It has to be stored securely. Everyone mentions the RIR problems with legacy information that they have in there, which isn't necessarily complete, isn't necessarily completely accurate up to the minute. And then you have to have some mechanism. This information isn't static. You have to have some mechanism for changing the information. And you have to have a model for who is allowed to authorize those changes. Some mechanism for querying this information securely so that you know that it came from the legitimate authority with the appropriate authorization. There's been work on this in the RPSL language. There was an RFC written about how to do security information in the RPSL objects. Whether that's adequate or not, I don't know. From the information that you hear of people being able to hijack addresses in the RIRs by sending messages to the appropriate person that's believed and the change is implemented, one gets the idea that perhaps they're not employing the strongest security model at the moment. And then you have the authority. You need some way to communicate this secure information to the appropriate routers, and whether that is some sort of a periodic download, whether it's inline information, is a question to be worked out. Okay. Then origination and AS path adjacency protection. AS path adjacency protection has been talked of in a couple of different realms. Brandon Smith and J.J. Garcia Luna Aceves of UC Santa Barbara, I think, did some work on this many years ago, and the SOBGP work has come out much more recently. The idea there is to check the AS path that you get to see whether or not the adjacent ASs in the AS path do actually have some sort of an peering arrangement. Is this path, in any sense, a feasible path? So you need some way to secure the transmission of this adjacency of information. Do you want to do the transmission in line with the security provided by some sort of digital signature? Do you want to do the information in perhaps the same database that has the addresses? Could peering arrangements be represented there? And then you have the same sort of problems. Are they storing it securely? Is there a way to change that information securely? Can you get it from them securely? Then all of this has certain processing demands that get added onto the work that every router will have to be doing. If the information is being done in line, you have to be doing the signatures in line. Now, this information doesn't actually change all that often, so it shouldn't be too much of a problem to be doing the crypto signatures. But verification is something that has to be done whenever you get new information. You have to have a mechanism for storing the secured information and any related security stuff that has to go into verifying it, like the keys. How do you get the keys? How do you know the keys belong to the same person? And then, of course, you have to check the AS path when you get it against this security information. And how much of a problem is it to do that check? That each of the pairwise ASs have a peering adjacency represented in the secure information you've received. And then, are there any residual vulnerabilities? Once you know that the ASs have legitimate peers, does that really tell you, are there ways to attack the BGP sessions by using that information, by using that sort of check? Okay, and then finally, the most secure stuff, the stuff with the most stringent requirement on the route protection is using nested signatures. This is something, if those of you have ever heard of SBGP work done in BBN. There are digital signatures which protect every prefix of the AS path. The protection, because it's supposed to ensure that the ASs have actually promised that they pass that traffic on that route. The protection is usually passed in line. There are certain processing demands generating the signatures in line as the route is being produced, verifying in line or as often as you decide you need them, storing the secured information as usual, related security stuff like the keys and how you know you can protect the keys. There's a certain amount of engineering that you can do to take advantage of the fact that the announcements are fairly redundant, and therefore it might be possible to not have to check everything every time. You checked it the last time it showed up, maybe it's still good. And the same idea, what residual vulnerabilities do you have when you're using this protection? Okay, so that's it. That's the sequence of protections.
Blaine Christian. Ooh, it's loud. Yes, just trying to wake everybody up. All right. My name is Blaine Christian. I'm currently with KMC Telecom, former unit. This is BGP security requirements. It's a draft that we're working on for the IETF. What I'm trying to do is portray the needs of the operators, that is you, to the IETF with respect to BGP security. And obviously I need your help. So, in the requirements, we'll go over the scope, the deployment requirements, the trust models, the AS path, NLRIs, address allocation, logging, tracking, transport protection, and the current proposed systems. The RPSec working group within the IETF is currently documenting requirements. What we're considering in scope are things like originating false data, routing database integrity, and peering integrity. What's being considered out of scope is anything which does not directly manipulate BGP. We're not going to try and cover the forwarding path at all with respect to packets. So we're not going to try and solve that problem. So a little more about what's in scope. What we're trying to do is inform the BGP security mechanisms that people are trying to develop. And you've already seen mentioned the SOBGP, SPBGP, SPV, I think the other one's IRV. What we're trying to do is create the baseline requirements so that when the IETF is trying to make the decision about how they're going to modify or change or make new drafts regarding BGP, they're going to take this into account. We're not trying to perfect things. We're trying to get it so that we'll actually have something that we can deploy, which means it's probably not going to be the best and the most secure. It's going to be the deployable and as secure as we can get it. So we're going to consider what works in the real world. We're going to actually review what's working right now in the real world and try and take advantage of it. Deployment requirements. This was a fun one. Great initial topic of conversation. It should not, and I don't know if, I'm sure most people here are familiar with IETF terminology when we say should and must. So it should not slow down BGP convergence. We think it's going to be rather hard to solve that, but it's a goal that we're supposed to strive for. So it's a should rather than a must. A must would make it very difficult for us to find any way to secure the system. The convergence speed is absolutely critical. We all have enough problems getting BGP to converge right now. We don't need to make it slower. Of great concern when BGP is converging is that initial convergence as well, which is what the cryptographic systems need to take into account, that it's not the steady state that we're concerned about as much as I've just lost my BGP session. It just came back up, and it's feeding me tons and tons of routes right now. BGP on the wire optimizations, such as packing, should not be impacted. This is where you aggregate information within the advertisements to speed things up. It should not be impacted by the security mechanisms and the verification of the routing information, which is I've determined that this is a valid prefix or AS path, needs to happen real time if it can. But we may have to go periodic, especially for the initial deployment, because we can't do everything right from the start. So it must be incrementally deployable. That's a key factor for all of us, obviously. We must be able to handle secure and unsecure routes in the same way. It should make, we should work to make decisions that are secure, but we should be able to run unsecure as well. We must allow BGP speakers running in an unsecure environment to peer with speakers running in a secure environment. That's pretty much makes sense. We must use backwards compatible message formatting in it, and so on. That's so that we can talk BGP v4 people still. It should allow a BGP speaker to tell the difference between an altered secure route and an unsecure route. That's one that's going to be rather interesting to try to do, and that's why it's a should. Deployment requirements must provide a local trust decision point. The trust model must provide local policy implementation for routing information. That means that internal to the router and internal to the AS, your decision should be your own as to what you do with those advertisements. So we need to be able to use the current models of policy and act on it in the same way that the current models do. We want to leave the final decision on how to act up to the local AS. Again, this is we don't want to impact internal operations of any of the networks. We want to just help improve the security of the advertisements. Allow for variability in different environments and internetworks. This is where we have to make some concessions or leave some room for networks that either need more security or less security. It must support a distributed trust model. That's one that I got a lot of feedback on early on from most of the operators. Some folks need a strictly secure model that fits within a distributed trust model. So if we say it must be distributed, we can also, within a distributed model, do a strict hierarchy. Large-scale internet networks built on a contractual basis, that's us, or most of us in this room, may find a distributed trust model more appropriate. By the way, a distributed trust model emulates business relationships, and that's what we're trying to push there. Again, a strict hierarchy subset of distributed trust model. It can encompass several modes of operation, and any proposed solution must be able to support a number of deployments that supports a distributed trust model. Routing information validation. We must verify the origin AS's authorization to advertise, and this goes back to Sandy's presentation, and I think you've heard it a few times. What does it mean to authorize? The trust model this is the critical area for the trust model. In some environments, the only acceptable means is to have a strict hierarchy and to be able to trace it back to an originating source. In other environments, a web of trust or distributed trust may be more appropriate. Just an example of routing information validation. You can see how the prefixes are advertised across those routers. Must verify the AS path corresponds to a valid path in the internetwork. Does the path 4321 exist, and did or could the advertisement traverse it? There's relation and non-repudiation here, which I'm going to talk about just in a few minutes. Basically, being able to track down who advertised what to you and be able to talk to them about it. We must ensure the first element of the AS path is the same as the transmitting peer's AS. This is one of the things that I hope really will make it out of this. It's not clear of any use that folks have, and I'm sure we'll have some discussion on this later, for using someone else's AS in your eBGP session. Logging and or tracking. A couple of these are ones that just seem to slip by when people are setting security requirements. Logging, tracking is one of them. A good detection system, an IDS system, should allow you to identify that someone's inserted bogus information. So one of the things that the draft attempts to push forward is that the methods for logging and tracking information need to be standardized so that any router that you log into or gather information from should report in a format that you can correlate with other types of routers. So that might be an area of focus. It must provide for logging. Oh, by the way, the should for non-repudiation is that it's non-repudiation gets to be a legal term, and folks are very nervous about use of that term, especially security folks apparently. And the reason for nervousness is understood. If you've said that you're able to non-repudiate every update, that means that any mistake could be blamed on you. Must be able to provide for logging. Again, that's in a standard format. So, transport protection. The mechanism that is used to secure origin and AS path should include transport protection. In other words, we're already very, very close, and we need to solve the TCP MD5 and IPsec complexity issues already. So what would help immensely in terms of the operators is to be able to use the existing transport protection or to modify the existing transport protection system such that it takes into account or it works with the origination of prefixes system. What I pushed for, just in terms of ease of implementation, is a single key per AS. That single key being the same one that secures your system security with your peers, as well as your origination. So, questions. How should the IETF handle proposed security mechanisms? As we've stated, there's several. Should we form a design team, advance any proposed system and requirements, and revisit it? Any other options? We're looking for input on this. And with that, I think it's going to be Danny's slide. So, please.
So I didn't actually have a slide till about 14 minutes ago. So I'm kind of the gratuitous panel member. I was just setting up here because I was involved in some of the initial work, the generic routing protocol security stuff, and helping Russ and everybody you see up here kick the work off in the IETF. So I actually just had a couple of questions. I wanted to get a show of hands from folks about how many people actually care about this in the room. So, all right, that's great. So with the next question here is, how many of you have actually been involved or participated in any way with this work in the IETF? That's all I have. So if that doesn't speak for itself, right? I mean, myself and a number of other folks, there seem to be like kind of a core team that that are doing a lot of work with this. This isn't the sexy thing, and it's not immediately deployable and whatnot, but it affects everyone in the room. And so my point there, and we've done the same thing with Apricot and RIPE, and we talked to the folks there about generic routing protocol security stuff and the documents, and they've been posted in NANOG and some of the other the RIPE stuff and some of the other working operator areas a number of times. And your feedback matters, and it doesn't cost anything to become involved with this. It's just a matter of your time and getting involved, at this stage. And so I think the show of hands there with the second question kind of speaks for itself. So if you actually care about this, then you should become involved. Otherwise, we don't want to hear your criticism in a few months when you see something published. Okay, so that's it. That's all that I actually had. So it's back to you.
All right, so we'd like to hear from you, the community. For instance, as Danny said, it's not sexy. It also doesn't make you any money, probably at all. However, it may be the subject of future RFPs you receive. I don't know, from potential customers, maybe as part of government procurement requirements. Who knows? Or liability insurance. So. It may become important to you in ways that you don't foresee, or that none of us foresee. And hard to say what if we want those things to happen, but the time to take the reins is now, obviously. And we'd like to hear from you. For instance, the question of the AS path security has been possibly the most hotly debated one on the email list, and we'd like to hear from people, for instance, on that topic of Lane.
Actually, I wanted to make a point. Russ came up here to point out that the path of the routing update does not necessarily traverse the AS path, and that's going to be one of the points that we need to keep in mind.
Right. So please come up. Sandy has something else to say, and I see some other shadowy figure making his way to the mic. But Sandy,
Or it's at least a question we need to keep in mind. Right. Is that true? Isn't that true? What relation does that have?
Sandy.
I'm actually interested in the second level of the sequence that I talked about, the ability to authorize and authenticate origination of addresses. The AS path is protection is very contentious, but I don't think that I think that if we do not solve the problem of being able to authorize and authenticate address advertisements, there's no point of going to the additional step of looking at how we protect the AS path. So anyone who has comments about how they might feel about databases that would have that information, with the requirements for those databases, the requirements for interaction with those databases, would be interested in hearing those kinds of words.
So we'll take that to mean everyone's cool with just using the IRR. Come on, please. Somebody come up. Say anything good, bad, or indifferent. What do you think should happen? What do you think should not happen? I mean that's possibly a deployment implementation or deployment detail that's a little further out, but it's not too soon to start discussing it, thinking about it, forming a vision. Somebody's making his way to the mic. That's great. Please state your name and all that.
David Barak, SBC. Just a question to Blaine about the authentication. If you have one key, however you do it per AS, how do you change it?
That's the question for the security people. It's going to be
Okay, so that's
a
their
good question.
problem,
That's
right?
their problem.
Got it.
I'm just an operator.
There's this old joke that says, I'll ask you myself a question and you ask yourself a question. And whoever can answer their own question wins. And my question is, how does the rabbit get to the bottom of the hole? Well, it starts at the bottom and digs to the top. And the victim naturally says, well, how does he get to the bottom? Ah, that's your question. So that's what I think of when people say, set a requirement and then say, and the security people will solve this for us.
Well, key rolling is one of the things that we put in the requirements document. I certainly didn't want to presume, from my perspective, to state how that sort of thing would be accomplished. So raising as an operator trying to feed into this forum, if I raise anything that smells like a solution, I get smacked. So instead of me trying to set solutions, what I'm trying to do with this document at least is set requirements and see if we can find solutions that fit them. There are several mechanisms available for rolling keys that they could have you could actually set it once and then forget it and let it roll, for example, is one mechanism. Then how do you set it again? So there are mechanisms out there for changing keys. The TCP MD5 version of changing keys is horrible, and I think we all realize that. There's other, and maybe Sandy can speak to at least one or two of the methods of changing keys that. All right, no, okay. Maybe someone can speak to some of the methods for changing keys, but it's an important topic, I agree.
Well, there's also the point that if you have one key per AS, that means that each of your peers has to be willing to peer with you with that type of cryptography. And that isn't always the case. And if you have different peers who want to use different types of cryptography, you're not going to be able to use just one key.
And we did make that a should, I think, as a result of that exact question.
Hello, my name is Richard Jimerson from Aaron. I just wanted to state for everyone here that the RIRs are very interested participants and observers of what's going on inside the IETF in regard to BGP security. And state that there is a organizational meeting of RIR staffs going on in the coming weeks at the Apricot meeting in Kyoto. They're actually going to sit down and talk about everything that's on the table and go into a higher phase of organization amongst the RIRs themselves to prepare for a soon-to-come and eventual set of changes that will take place with each of us that will involve the RIR databases. And it's risen to a top level of priority inside management of the RIRs, and just generally state for everyone that we are paying attention, we are participating, and we are ready to make some quite significant changes and moving forward.
One question for you. Are you willing to do BGP?
I think they'd be willing to do BGP, yeah.
Okay, just checking.
Yeah.
That was one of the concerns I'd heard mentioned from someone at IANA, that they didn't want to be, sitting sort of at the top of a tree, being the single source of potential failure. So.
Right. I would reserve that type of decision for the people who are more closely participating in the process, but they are talking about it a great deal.
Can you mention anything about what you have planned to address as far as security is concerned?
Well, at each of the RIRs, when it comes to the security of the registration objects, we've each been independently working inside of our regions to provide better options for folks. For instance, I can only speak for Aaron here. Beginning last year, it became an option for points of contact in the Aaron region to use cryptographic authentication to manage their objects in the Aaron database. Each of the other regions have things like that going on as well. Aaron is actually running an X509 certificate authority right now to enable that activity. When it comes to secure BGP, we view that as not a per RAR individual with your community type deal. It's something that we consider to be a coordinated effort amongst us, and that's why we're holding this planning meeting in Kyoto next month to talk about it.
Don Smith, question. Maybe I'm overstating the obvious, but if you have a shared secret key that you share with everyone, it's not much of a secret.
Well, this is public-private keys, right?
Oh, okay. That's not the way it's implemented today, though, right?
Sorry?
That's not the way the MD5 is implemented today.
No, and that's
Okay.
that's the problem, and that's
Okay.
why that's a big reason why MD5 is so horrible, right?
Manish Career Merit. My question is a little bit more basic. It's actually a question about what used to be very important to the IETF. That is there a working code, and if so, what are the projects that that are implementing pieces of this and that we can start using?
We should ask some router vendors to step up now. I saw one up at the microphone, Russ. And Pedro is coming up. All right.
So, one question for you. Pedro Marques, Juniper Networks. Why don't you decouple the problem of figuring out which ASs are allowed to advertise want from BGP? Even if you need to add some information to the routing system to propagate that could always be done opaquely.
I think the concern, at least my concern as an operator, is anything that pulls the distribution of IP information sort of out of the network itself. In terms of keeping things, that's one of the reasons why we were kind of fond of keeping BGP in-band, right? If you had an L2 network and you dropped a session, BGP knew about it. Okay, so from my perspective at least, I think that the more closely attuned the security information for those prefixes is with BGP, the safer it is as a means of distribution. I don't disagree that it can be decoupled. I'm just that would be my first blush at it.
It's probably the hardest problem you have to solve is figuring out, how to delegate the authority of assigning and advertising prefixes, you don't need to modify BGP to actually do any of that. And
So-
you could go ahead, solve that problem. That information can be transported transparently into BGP, and you could not
So how-
toggle the two things together.
So I mentioned database downloads as one possibility of how to get that sort of information around. There's a bit of a problem if you want to protect whether the AS has been allocated the address and also whether the AS is currently advertising the address. The currently part of it kind of implies that it needs to get transmitted at something with a little more immediacy than a database download. There have been people who have objected to the idea of the database download as presenting somewhat of a chicken and egg problem. If your routing's not working, how are you going to get to the database to do the download?
Where's Bill Manning? I think that was one of his favorite things.
That's something we've said before. I think that in reply to Pedro a little bit, since he's coming back up here.
Just identify.
By the way, I'm Russ White, Cisco routing geek, architect, all that stuff. Anyway, is that part of the problem we're facing is if the distribution of the routing information, for instance, what Sandy's talking about with a downloaded database or something like that, is so far off of current BGP convergence times, which aren't very fast but could get faster in the future, then you end up in a situation where you have the database saying one thing that's secure and the routing information in the system saying something different, and you have to figure out which one to believe, and et cetera, and you don't want to slow down BGP convergence waiting on a secure database and things like that. I'm not saying that database download is valid or invalid in that environment. I'm just saying that's a problem that we come into when we look at Blaine's requirements on the operational perspective.
Just a quick procedural comment. There's 2 people left in line. After that, we'll cut it off so we can have lunch.
So I think that if you can prove that you can solve this problem with a database download, we can stuff the data into BGP. That's not the problem.
Okay.
I think you have to prove yet that the problem of delegating can be solved. And to Russ's comment of time lag between database, is the time lag because of the database distribution or because the delegation mechanism itself is a time lag? And there's 2 problems: generating information and distributing information. If you assume that the second is not there, can you still solve the generating?
And I think that's one of the things that the values that I think you get out of the distributed trust model, right? Because you're going to hear it from a few different sources, and hopefully that can help speed things up as opposed to kind of bottlenecking your way up. But I
Dan Golding, just as someone who's not really involved with this particular process, just as a network engineer, a quick question. This seems to be, as an observer, sort of a okay, better, best sort of thing where people are going for best when they could really easily have sort of okay, and it's been going for a long time. Is there some, for the people involved with the process, is there some bias or some reason they're not interested in just using DNS for this? I mean, DNS is a database that has, IP addresses. It's controlled by the people who control the IP addresses. You put in a resource record for an AS number, and, at that point you have, a positive association between prefix and AS number, and you've gotten maybe 75% of what you want and eliminated a lot of complicated issues.
Well, I'll give you just
I was going to say, I know that there's been a proposal along those lines 7 to 8 years ago or so. And I don't know that it ever went anywhere. I mean, it seemed to get somewhat lukewarm reception. I mean, I remember NANOG in '98 or something, and it was presented, and it, for reasons I don't really recall, it didn't go very far. But feel free to try and reawaken it. I think that sounds, I always kind of liked it.
One of the and this is just going to be unadulterated opinion, and it's not representative of the entire group, I suspect. But one of the things that I always had trouble with was anytime I had to make my router go external to the router itself or external to the set of routers to discover its brain. What concerns me is that, and this actually goes back to the database as well, right? If we externalize the process for securing and distributing this information, we're creating a situation where problems with the servers of the services make an impossible situation for recovery. So I really like the router. Again, this is all my personal opinion. I really like the router to be able to discover just about everything that it needs to about itself to bring up IP, and then I like to have the servers for all the services and stuff. So I guess again, that's just my opinion, and there's lots of those in this room. So, but we can all talk about it later. I suspect everybody now wants to eat lunch, unless you have a.
Tony,
That's it.
the DNS problem, the DNSSEC stuff came up with the same chicken and egg problem in one of its problem, and you can go to Randy Bush
Okay.
for the original stuff.
Oh, there's Sue over there. Yep. Okay. Right. So there's some background on the DNS approach. Just on the topic of the running code, that's sort of out of scope of our exact working group, but I'm pretty sure that SBGP, there is some code available. I don't know much more about it. If you do, Google search, you can probably find the homepage for SBGP and see whatever you can find there. Thank you very much.
I have to presume that